Hello everyone, I'm Max, and I'm presenting the paper VIEScore towards explainable metric for conditional image synthesis evaluation. Our motivation is that we believe the metrics in the future will provide not just the score, but also the rationale. We want to enable the understanding of each judgment, and we also notice that the traditional metrics are not task-aware, which means it cannot be broadly adapted into different tasks. This implies the traditional metrics lack of task awareness and the reasoning ability. To address this issue, we propose VIEScore, known as Visual Instruction-guided Explainable score, to tackle both downsides. The main idea is that we want to leverage a multimodal large language model, known as MLLM, to do the evaluation for us. In VIEScore, all the input conditions, synthesized image, and rating instructions are fed together to the MLLM in one pass. Then we retrieve the score in any scale and the rationale. In this example, we can see this is a multi-concept image composition task where the goal is to synthesize an image that contains both concept and align with the prompt input. The input conditions and the synthesized image are fed to a MLLM with a corresponding instruction prompt, thus get the score results and the reasoning. The image here is rated through to human perspective, the semantic consistency to raise the conditions, and the synthesized image alignment in the range of 0 to 10, while perceptual quality assess the image fidelity and the naturalness in the similar sense. To comprehensively test this method out, we conducted a study on a wide range of image synthesis tests to compare the correlations. The goal is to find out whether at current stage we can replace the traditional metrics with our proposed VIEScore in image evaluation task. So the flow is like the figure on the right. We have several tasks on the top, and then for each task we fed a task-aware instruction, the conditions, and the synthesized image to the MLLM. At the same time, we asked 3 humans to do the same evaluation. Then we compare the results to check the Spearman correlation. But how can we get this kind of human labeled data? So thanks to the work ImageN Hub, that work has provided a large-scale human study on around 30 models across 7 image synthesis tasks, which involve of around more than 10K annotations. Each instance are rated by 3 human raters, and they contain the SC, which is the semantic consistency score, to check whether the conditions and the image is aligned. PQ for the perceptual quality to check the realism and the lateral sense, and the overall score, which is the geometric mean of both aspects. In our experiment, we embed the human rating guidelines in our prompt, which cover the 7 tasks including the text-to-image generation, the mask-guided image editing, and the subject-driven image generation, and also the subject-driven image editing, then the multi-concept image composition, and the control-guided image generation. So in those tasks, from the figure you can see those C1, 2, 3 are actually the conditions according to the task, and Y is the synthesized image. With this all set, we run our VIEScore across 7 tasks with different MLLM backbones across all the 7 tasks we just mentioned. We can see the human-to-human correlation is around 0.45, and GPT-4o achieves on-par correlation with human. Gemini 1.5 Pro also achieved a relatively high correlation, but not as good as GPT-4o. Then We also noticed the performance of closed-source MLLMs are generally much better than the open-source MLLMs, marking a big gap in this reasoning ability. We also noticed that when the in-context learning, that is, the one-shot setting is applied, the correlation decreased. We look into the reasonings and we realize that general MLLMs struggle in in-context learning when multiple images exist. The model will get confused. For example, a girl image is fed as an example to teach the model how to evaluate a cat image. Then, the model started rating based on the girl image and also the cat image. This is not what we wanted. This is likely caused by the poor ability of the MLLMs to understand multiple images. So we also explored the correlation to human based on VIEScore and the traditional metrics across all the 7 image synthesized tasks from ImageNHub. We noticed that VIEScore beats traditional metrics in literally every task, such as the clip score from the text to image generation task, the LPIPS from the image editing task, and also Dino metric from the subject-driven image generation task. So I really wish that we can simply start using VIEScore now, but there are still obstacles for us to deploy explainable metrics at current state. One big issue is that we found that MLLMs often struggle to see the minor differences in two similar content images, as MLLM tend to understand the images at structure level but not detail enough. There are still room to improve, and we believe I believe VIEScore with MLLMs will be a mainstream evaluation method in the near future, as in practice, multiple image QA is an area coming with many applications, and the MLLMs will eventually be improved in the future. That means the VIEScore we proposed will be more robust. Finally, we encourage open science, and we have already released our modularized code on GitHub so that other researchers can pick up our work with ease. Thank you for listening.